This is Applied Data Science. This is Assignment 8 Tutorial in RStudio, helping you to get ready to do the assignment with similar data and similar challenges, but requiring your adaptation of this code and approach. So we're up to splitting the data set into training and test sets. At this line, we create a specific integral sample size, which is supposed to be close to 0.8, 80%. We then set the random seed, knowing that we want to have a deterministic process that we can repeat. So the 2018 is arbitrary, but by setting the random seed, we can reproduce this, which is useful for testing purposes. TI will be the row indices of the training set, and the sample command is that randomization step. So train.auto is that subset of the data set for training with the row indices corresponding to TI. Test.auto is the opposite. The minus TI means that all but those rows are subsetted out of auto. And you know str gives us information about the training and test sets with that str or structure command. So we can see that we have 318 observations or rows in the training set and 80 rows in the test set. So we're ready to do our predictive modeling now, our machine learning. With linear regression, the main function is LM for linear model. And this first argument is quite interesting, and I invite you to look closely into this. It is not a simple thing. It represents a relationship or a function which is then used symbolically by the LM command. So here we're trying to model dependent variable MPG using some linear combination of weight, year, and horsepower. So this is a three-dimensional linear regression. And using the training set, of course. So we run that. That generates the linear model, which we were calling MyLM. Then we take that model and use it to predict some results. So there we're taking the test set, not the results of the test, not the labels, but we're actually using just the weight, year, and horsepower and generating results. And then this summary compares the results of the prediction with the actual MPG labeled in the data set. So that summary gives us, the way it's done here, gives us some information about the differences, also known as the residuals. Next algorithm, k-means clustering. Recall this is an unsupervised method, so we're not using the labels. We're using some descriptors and seeing if we can cluster and what those clusters might tell us. So k-means is the command. The parameter 2 tells us the k. So when we are clustering, that's the number of neighbors we consider. Refer you back to the k-means tutorials and resources. So now my KM has been run, and we can plot we can do a plot which gives us some idea as to whether these clusters correspond with some of the descriptors. So this command is a bit complicated, but the coloration is indicating the clustering from the k-means. Col is color. The coordinates of the plot itself are weight and year, y and x. And the character used to do the scatter plotting depends on this logical field efficiency. So if you have good eyes, you can see circles and squares. And we can see that the clustering does correspond with some weight and year landscape or threshold. So it seems to be correlated or corresponding with that. Creating another data frame from that and basically merging the clustering with the auto frame, data frame. We can create a table and kind of look at how those clusters correspond with fuel efficiency. And looking at that, not so great. Next method, classification tree. And recall that decision trees can be used for classification or regression, which is why they're also known as CART, classification and regression trees. We're going to use the rpart package. And again, this first argument to the function should be understood symbolically. It's asking this function to model this dependent variable, fuel efficient, based on some linear combination, or not linear combination, but some partitioning based on the variables, the independent variables, cylinders, horsepower, weight, acceleration, and year. So we run that. We create a new data frame based on those predictions, and we summarize the results. This is simply asking us, it's simply looking at the 10th, 11th, and 12th columns of this data frame, which is the results of the modeling. And so we're seeing how well the partitioning works for the fuel efficient true and false categories. With the regression tree, remember, we're not trying to predict or model a categorical variable like a yes or no fuel efficiency, but rather a real valued variable, miles per gallon in this case. So we again run the command, but instead of with a Boolean dependent variable, with a real valued or numerical variable as dependent variable. And so again, we add the results onto a data frame for analysis purposes. We summarize the differences between the predicted and actual values. That gives us some idea. And we can also compute a correlation coefficient between the predicted and actual values, which in this case is 0.867, which is quite a close correlation. Okay, I think that's it.